Hi guys. As you know, I've got COVID, and so I needed to stay isolated for 1 week, and but I'm feeling quite well now today, so I think I will be able to make some videos for you guys for to help your study. Um, as you know, we are in such a tight schedule to try to finish the curriculum in time um, before the exam, right? So today I'm going to make a video about 25 to 30 minutes, but of course during the video you might need to pause the video for your own working, and sometimes I will ask you to pause the video if you can. Right, and so today we are going to talk about the standard score. Okay, so yeah, you don't need to copy anything yet. Okay, so I'm going back to your handouts pretty quickly, just provide you some background because I skipped some parts of the content in my PowerPoint, so I need to give you some background. Okay, so standard score, we use a Z to represent standard score. And we last time we learned that if that's a normal distribution, okay, so if that's a normal uh, distribution, all right, what it looks like a normal distribution. All right, let me draw it properly. Okay, so this is our y-axis, x-axis. Okay. Okay, so the probability density function of normal distribution will looks like. Okay, it's not completely um, like this, but just okay. So just bear with me. Okay, so it's like a bell shape. Okay, and we understand the middle points, what we call the mean, or the expected value of x of the random variable, which is the normal random variable, and also that's another. So the width is measured by. So the width is measured by the standard deviation. We call it sigma. So there are two parameters for the normal distribution, sigma and mean. All right, so let's say if I try to find the probability, for example, I'm trying to find probability x less than a certain value, let's say, which is you can say any number, okay, just x, right? So let's say that x is here. All right, so what does it mean? That means actually you need to find the area on the left hand side of that x. All right, so we understand what you're going to do here is to do an integration from negative infinity to x for the probability density function of this one, right? But okay, but that's a standard normal distribution. Apart from the normal distribution, that's a standard normal distribution. Okay, so standard normal distribution looks like this one, except you see the mean must be 0. Okay, so that would be the z. Okay, so I'm going to tell you what random variable I'm going to use, and standard deviation is 1. So that's the standard normal distribution. For standard normal distribution, sometimes we change the random variable, not using x, but using z. Okay, so we're using z instead of x, right? And what's the relationship between these two distribution? Okay, so this is very important. That's a very important relationship between the two distribution. Because if you try to find the probability of x less than in the standard normal distribution, in the just the normal distribution on the left hand side, you can do this with, you can transform that um, probability by finding the uh, probability using a standard normal distribution. Let me say again, you can do that on a standard normal distribution. How can we do that? First of all, you need a transformation, and the transformation would be like, okay, so I'm going to write the transformation here. Okay, sorry, my handwriting here is not good, I know. Okay, the transformation is you make that z equals x minus its mean over its standard deviation, the sigma. All right, so that's the transformation. Once you've done that transformation, you can find the probability by using the transformation equals this one. Okay, so that means you can find value here, which is x minus mean over sigma. And as long as you can find the area on the left hand side of that line, then that would be the same area. That would be the same area as the one you've got in the normal distribution. So that means you can always find the same area in a normal distribution with any mean mu and any standard deviation sigma by using the standard normal distribution with mean 0 and standard deviation 1. Okay, so that's a very important transformation in normal distribution and in statistics in general. Why? Because there are millions or what 100 millions of normal distribution with all sorts of mean and standard deviation. There are limitless combination of those numbers, parameters, I should say. But for standard normal distribution, it's always the same distribution, isn't it? So that's why it's very useful. Okay, I just try to convince you that that transformation is very important, because once you know the z value, okay, so that basically means what would be the relative position of that score in a standard normal distribution. Okay, and we can interpret that a little bit. How about x minus mean? X minus mean, you can see just the difference, okay, between x and the mean, right? And you divide by sigma. That means how many, so overall, that means how many standard deviation. So overall, that means how many standard deviation the x value is away from its mean. All right. Let me give you some numbers to have a better illustration. Okay, for example, if that's a normal distribution, we mean 10 kilogram, which means the mass of something, mass of babies. That value too heavy. Who cares? All right, mass of possibly babies of certain mammals like giants, panda. Right, 10 kilogram, and standard deviation is 2 kilogram. All right. So if there's a giant panda with a mass um, like a 12 kilogram, so you see that obviously is heavier than the average panda's mass, but how much is heavier in terms of how many times? The standard deviation, that mass is away from that mean. You can do the z-score. So if you use z-score to do it, so it's 12 minus 10 divided by 2. All right, then you will see that that's actually 1. So z-score means 1. That means you are 1 standard deviation heavier than the mean, which means that panda baby is heavier than normal, but it's not extremely heavier than normal. I hope that makes sense to you, right? So then let's go back to the handouts, right? So here's your handouts. Let's try to work on the handouts. All right. And okay, so standardized value means z. Okay, it just means z value. Data value means x minus mean divided by standard deviation of the normal curve. Okay, of course you must assume that x value belongs to a normal distribution. Okay, you can say that x value belongs to a normal distribution. Okay, when I write n, that means a normal distribution. Sometimes you can write a few more words. Normal distribution with mean and standard deviation. That's the way we say a random variable belongs to certain distribution. All right. And how about z? Now z belongs to a normal distribution, which is standard normal. So mean equals 0. Standard deviation means 1. All right. Okay, so here's very important idea. Positive z value indicates that the data value represented lies above the mean. Negative value, of course, below the mean. Okay, let's say when z equals 2, it means the value of normal variable, that means x, is what? So it means 2. So 2 standard deviation. Okay, and because it's positive, it's greater than the mean. But if z is minus 3, it means the value of normal distribution, normal variable, is 3 standard deviations less than or lower than the mean. Right? I hope that makes sense. All right. And then we are going to try to do some the example 4. All right. Okay. All right. So I give you the mean, standard deviation, and the random variable x. Remember that random variable x belongs to a normal distribution with mean and standard deviation, and z is just standard normal random variable. So means 20, and your sigma is 4 kilogram, x 24 kilogram. So is that x greater than normal? Yes. But how great it is, in what extent is greater than, right? So you can find the z-score. You just use your x value minus the mean divided by standard deviation. So 24 minus 20 divided by 4, so that would be just 1. So standard score is 1. 170, so second one, it looks like the height of adults, right? 170 centimeter and standard deviation 15 centimeter, x is 140 centimeter. Okay, so that x value is less than the mean. So again, use the same formula, and you need to go with 140 minus 170 divided by 15. So that becomes minus 2. So you see, whenever it's less than the mean, it must be negative. All right. So sometimes we might give you the z value. You need to go back to find the x value. All right. So the mean is 12, standard deviation 2. Can we go back to find the x? All right. So you can just write the formula here. X minus mean means 12, and that's 2. Okay. So to find the x, you need to multiply 2 there, multiply 2 to the right hand side becomes 8, and 8 plus 12 becomes 20. Okay, so it should be 22nd. Okay, all right. And here's another one, 26 and 4 as mean and standard deviation. How about minus 1.5? So it must be x minus 26 divided by 4. Okay, again, you need to multiply that 4 to the right hand side, minus 6. And then you plus 26 to the right hand side, and it becomes 20. Okay, another 20. Okay, so you see there are a few remarks. You see the standard score, you will never have any units. All right, because units are going to be cancelled out. But okay, normal normal random variable, you will have units sometimes, unless you don't have units for all other parameters. Otherwise, you will have the same units as the parameters for random variable x, but for z, for z, that's another story. All right, that's pretty much the algebra of z, which is not that difficult. So let's see some application, which is the more interesting part of normal for z-score, right? Or z values. Okay, Gabriel compare his academic results. So here this is the comparison. Compare is the keyword here with the class performance with the whole class. Assume the results from the class follow normal distribution with means and standard deviations in the following table. Justify Gabriel's best subject in terms of z values. Okay, so you need to justify Gabriel's best subject. Okay, so wait a minute. So if Gabriel's report card was like this, so it seems like Gabriel have the highest mark. So Gabriel might tell his mom, my literature is my best subject. But is that really true when we compare the whole class performance? Because some subjects are more difficult than others. So for example, methods should be more difficult than a lot more other subjects, right? And so if you can't get as high a mark in methods, and then it's quite natural, and you can't say just you just based on your result, you can't just say method is my worst subject because you got the lowest mark. And at the same time, you can't just claim a subject with the highest mark is your best subject for the same reason. Okay, so can we do it statistically with much reasonable method to make a justification for that. Yes. So you can always try to find the z-score for each subject. All right. For example, for math. Okay, so let's say mean is just mean, standard deviation, Gabriel score. So what that score means, that score should be the x value, not the z value. So I'm going to find the z value here. So how can I find the z value here? So let's say for math, the z value should be x value minus mean standard deviation over standard deviation again. Okay, right, that's what I'm going to do. Okay, so after some calculation, I will get 1.23529. Okay, so let's just write 1.24. All right, for physics. Okay, so can you just pause the video, please? If the teacher can help, much appreciated. Okay, so you pause the video. I'm not going to pause. I just keep talking, but you pause the video right now for 5 minutes, so you can have a you can work on those z values, and if you have any question, you can discuss among yourself. Thank you. Right. So 5 minutes. Okay. Um, I might not have enough time to because I'm feeling a little bit dizzy now. Sorry. Okay. Possibly not a very good idea. All right. I hope I'm not making any mistake. So I just switch back to PowerPoint, so it's just easier for me. All right. So you can see just play slides. All right. So that's just my PowerPoint and the math, physics, literature, history. Okay, so it seems like, okay, although literature Gabriel got the highest mark, but the standard score for literature was actually quite low, it's 0.608, and the highest standard score is actually physics. And and also you can say Gabriel is doing a good job in terms of z-score. He got only one subject is lower than the average, which is history. But the question is about the best subject. So the best subject must be physics. So that's why this is very important idea to have a z-score. Okay, I try to give you the idea so you understand why do we need to do that? Why do we need to calculate all these z-scores things? All right, and why? So are they really necessary? I think so. All right. Okay, and comparing samples. So you can read the questions. So it's just about swimming context. Okay, so Shirley is trying to represent Australian uh, swimming team. I suppose I forgot what question I'm putting here. All right. So and again, the idea is okay. Shirley Shirley needs her best time to be faster than the Australian average among all professional swimmers by at least 1.3 standard deviation. So really read that sentence again. Shirley needs her best time to be faster than the Australian average among all the professional swimmers by at least 1.3 standard deviation. What does it mean? That means your z-score need to be 1.3 at least. So your z-score need to be greater than or equals to 1.3. Okay, why it is so? Because you need to be elite. You need to be elite swimmers to represent your country. And we know um, Australia is very um, so the swimming team in Australia is world class. So that's why you need to be really, really good. You need to be at least 1.3 standard, great, faster. Okay, but here about being faster, you need to be a little bit careful. So in terms of time, being faster, that actually means your time should be shorter, right? So that means actually your standard score, yes, it's 1.3, but it should be negative 1.3. I thought I did something wrong. Sorry about that. I blame the COVID for me to make that mistake. When I said at least 1.3 standard deviation, that means her z-score should be less than or equal to minus 1.3. Sorry for the mistake. I really did that. I think I should better finish this pretty quickly. All right. So 15-meter butterfly minus 1.6. Okay, so you could calculate that. So try to spend some time calculate all the standard score. Can you? Can do that? All right. And okay, just pause for 5 minutes so you can work on all the C score and make your decision which contest you can represent her country. Okay, and okay, I think that so if you've done your results, let's try to get all the full Z scores and you can see um, okay, so it seems like 50-meter butterfly minus 1.6, 50-meter freestyle minus 1.2, and 100-meter Z score minus 1.32. So that means, yeah, she need to be 1.3 at least. So I think, so it's quite obvious now. So she could only take parts in 15-meter butterfly and also 100-meter freestyle. Yeah, you see that? That's the conclusion, right? Okay, so there are plenty of examples here. Can you spend some time work through those questions? Thank you. I will try to make another video for the next lesson. Okay, thanks for watching and thanks for your effort try to do the self-study, right? Really appreciate it. And thank you for the teacher helping me to show the video for you guys. All right, have a good day. Bye.